So now let's move to the hybrid parameters. For the hybrid parameters or H parameters, I1 and V2 are the independent variables. We have V1 is equal to H11 I1 plus H12 V2. Then our I2 equal to H21 I1 plus H22 V2. Now in matrix form, this is V1 I2 equal to the H parameters 11 H12 21 H22 times I1 V2. Now to solve for the H parameters, you need to short port 2 and apply a source at port 1. To solve for the H parameters, looking at the equations, if V2 is 0, meaning our port 2 is shorted. If port 2 is shorted, we can solve for H11 and H21. H11 is equal to V1 over I1. V2 is equal to 0. Our H21 equal to I2 over I1. V2 equals to 0. So next, to solve for H12 and H22, we need to have our I1 as 0. So I1 needs to be 0. So when I1 is 0, meaning our port 1 is open. So our H12 equal to V1 over V2 and I1 is 0. And our H22 equal to I2 over V2 and I1 equal to 0. The H parameters also have a equivalent circuit. So for port 1, have a resistance or an impedance series with a dependent voltage source. This V1 and I1. So V1 is just equivalent to H11 times I1 plus H12 V2. For port 2, V2 I2. So I2 is equivalent to H12 times I1 plus H2 V2. So we have admittance H22 times V2, which is the current at this branch, plus we have a parallel dependent current source, which has a value of H21 I1. So when you take a look at the equivalent circuit of a hybrid parameter, it's just like a combination of the Z parameters and the Y parameters. The figure shows how to solve for the hybrid parameters. For example, obtain the H parameters of the following network. First, let's label our V1 I1 and V2 I2. So this is our I1 V1, then our I2 and V2. Now for H11 and H21, V2 is equal to 0. For our port 2 is shorted. We have our H11 is equal to V1 over I1 V2 is equal to 0. Now, looking at this node, one node, the 100 ohm resistor and the 300 ohm resistor are connected in parallel. So we can simplify this circuit combining 100 and 300. Applying KVL at this loop, our V1 is just equal to 85 I1. Our V1 over I1 is our H11 equal to 85 ohms. Now for H21 is equal to I2 over I1, V2 equals to 0. Now to solve for H21, we apply nodal analysis. Let's label this node node B and this node as node Vx. This is our reference node. So KCL at B, our VB, just equivalent to 0 since it is directly connected to the reference. So we have VB minus negative 10Vx over 50 plus VB minus Vx over 300 minus I2 equals to 0. So VB equals to 0, then combining like terms, we have 59 over 300 Vx minus I2 equal to 0. Now looking at this figure, at the simplified circuit, our Vx is just equivalent to 75 times I1. So Vx in terms of I1 is 75 times I1. So substituting Vx here, this equation becomes 59 over 4I1 I2 equals to 0. So our I2 over I1 is our H21 equal to 59 over 4. Now for H12 and H22, our I1 is equal to 0, meaning our port 1 is open. So I1 is equal to 0. So if I1 is 0, meaning our V1 is just equivalent to Vx. Now looking at the circuit, if I1 equals to 0, meaning our 300 ohm resistor and 100 ohm resistor are connected in series. So we can apply VDT to express V1 in terms of V2. So by VDT, V1 is equal to 100 over 100 plus 100 is equal to 400 V2, or our V1 over V2 equal to H12 equal to 1/4. Now for our H22 is I2 over V2. So again, we apply nodal analysis. So let's label this as V2, and this is our reference node. So applying KCL at V2, negative I2 plus V2 plus 10 Vx over 50 plus V2 over 400 is equal to 0. Now our Vx is just equivalent to V1, and then we can express our V1 in terms of V2 using this equation. Our V1 is just equivalent to 1/4 V2. Substituting this value to here, we have negative I2 plus 29 over 400 V2 equals to 0. So our I2 over V2, which is our H22, equal to 29 over 400 S. The inverse hybrid parameters, or the G parameters. So for the G parameters, V1 and I1 are the independent variables. So we have this form, matrix I1 V2 is equal to the G parameters times V1 and I2. If we take a look at the equation, we can see that G is just the inverse of H, or H is just the inverse of